Hello and welcome to another one of D's ADD videos. Today we're going to be looking at this example of integration here. This is a slightly more advanced example. And when you're approaching any integral, you should have a game plan. Okay? You should have basically an arsenal of weapons of integration ready for you to use to try to solve this integral. All right, the first thing you should try is you should try to do these separately. Unfortunately, because of that radical, the square root right here, we're not able to do these individually. Only if they're added and subtracted can you use the power rule with the variable in the numerator. Okay? But if they're not added, subtracted, if they're divided, or in this case square rooted, or if they were raised to the fifth power, you have to do something different. Okay? Well, that something different might be some algebra or trig to rewrite the problem. But in this case, there's just a simple square root. Can't really do anything with that. There's no long division, or there's no separation of numerators, or any other type of algebraic manipulation that you can do to rewrite this problem. If there were, you could rewrite it and then do that integral. All right, so there's no trig here, so we can't use any trig identities. So we move on to the next weapon in our arsenal against integration. And the next thing is u substitution. Well, the only thing I can really let u equal is this 4 minus x squared, and the derivative is 2x, negative 2x actually. And you would need an x term on the outside in order for that to work. So you can't do u substitution. So what we try is the next thing. And sometimes this next tool, integration by parts, might work. Okay? You will find in math there are many paths to the same destination. So I would hope, though, that you practice enough of these problems to look at this and say, oh, that looks like a u sub. Wait, there's no x in front. Oh, wait, this is a number squared minus a variable squared. And you immediately go to trig sub. Okay? But it might work. It might not. That comes with practice. All right? That's the best I can tell you on that one. Now that we've decided it's trig substitution, you're going to assign your u and your a, okay? And it's easy for me to remember it's sine theta because when the number's first, I pick the first trig term. When we list the trig terms, sine is usually the first one we list out of all of them. So number first, sine first is the way I remember that. However, you got to remember it. Hopefully just by practicing a bunch, you'll remember. I know I keep harping on the whole practice thing, but I can't overemphasize that enough. It's better than any tutoring, better than any video or going over notes, just doing problems, especially for math and subjects like math. So here, if I let u squared equal x squared and a squared is equal to 4, I can then find out what u and a are by square rooting both sides. So when we square root both sides, you're going to get u equals x and a equals 2. Then at that point, you can set up the following trig substitution. This right here is the foundation for what we're going to be doing. Okay? And it also allows us to calculate what our d theta term is going to be by deriving your x term. So when you derive both sides, you're going to get dx, the derivative of sine is cosine. And then we do a d theta at the end of that. So now at this point, we are ready to plug in the trig terms. So wherever you see an x, you plug in a 2 sine theta. Right, because that's what the x was, squared under the square root. And then instead of dx, we plug in this whole term. That's what you get. Now when we simplify and square the sine term, this is our new problem right here. Okay? And with these, what you're going to want to do is you're going to want to factor out the common coefficient, then use the 1 minus sine squared is equal to cosine squared and simplify. So when you do all that, that's not the focus of this video. When you do all that, this is what's going to happen. So you factor out the 4, then you square root the 4 to give you 2. 1 minus cosine squared becomes cosine. I'm sorry. 1 minus sine squared becomes cosine squared. And then square root of cosine squared is cosine. And then cosine times cosine is cosine squared. Okay, the 2 came out in front, give you 4. This should be pretty straightforward. If not, go back and review your basic trig, identities, Pythagorean identities, and trig integration. So now at this point, you should know how to do this also from basic trig integration. You're going to use a power reduction formula. So let's do that. So when we do that, If you remember, cosine squared theta equals 1 plus cosine 2 theta over 2. If this was sine squared, this would be a minus sign right there. Okay? Then at that point, you separate, and you're going to do the integral d theta because of the 1, and the cosine 2 theta separately, and the 2 that was in the denominator came out 4 over 2. So the integral d theta is theta, that's pretty straightforward. But the integral of cosine 2 theta, so the integral of d theta is theta, the cosine 2 theta, most of you probably can go directly to this, but what you're doing is you're letting u equal 2 theta, deriving du over 2, and then here you get 1 half cosine u, the integral of cosine. Well, what do I derive to get cosine? Sine. So then you plug back in what u equals, and then that's that answer, all right? So now at this point, what we have to do is we have to solve this back in terms of trig. Okay? So this is what we have, and we have to go backwards with it. All right, to get the theta, you're going to need to solve this x equals 2 sine theta relationship for theta. So you divide by 2, then you arc sine both sides. Now what we need to do is figure out what's going on here with this sine 2 theta. Is you're going to take your sine theta is x over 2 and create this triangle. If you remember, sine's opposite over hypotenuse. So there's your opposite over hypotenuse. Then use your Pythagorean theorem to get the missing leg. And then cosine would be the adjacent over the hypotenuse. But you might say to me, well, there's no cosine here. Why are you saying cosine? Well, if you look at this, you can't really do sine 2 theta. This triangle is in terms of just theta. So what we have to do is we have to use a trig identity. So let's plug in our theta that we saw for here, and then plug in the trig identity, the double angle identity for sine 2 theta is 2 sine theta, cosine theta. Now that the coefficient of theta is 1, we can use this triangle to get rid of these terms. Actually, the sine theta, we already know sine theta is equal to x over 2. So cosine theta, we already know sine theta is equal to x over 2. So cosine theta would be this one over that one. So plug and chug, and when you do so, you get that here. The 2's will cancel, and then when you multiply everything out, you get this wonderful answer there, all right? I hope that's clarified things enough for you to try some trig sub problems. This was a pretty straightforward one. They can get a lot more complicated, so practice, practice, practice. Thank you, and have a nice day.